Friends, in the previous two videos in the steering system, we discussed about the introduction and as well as the rack and pinion mechanical steering system. Now in this video, I am going to talk about the power assisted rack and pinion system, which is being used in the present generation cars. In this power assisted steering system also, we'll discuss about rack and pinion steering system only. What is mean power assisted means? Here the hydraulic fluid acts as a power booster in this system. This is an evolution in the steering system because using the mechanical steering is laborious to the driver. If it is laborious in the cars itself, imagine the load on the driver or the effort required by the driver to steer a vehicle which is carrying heavy loads like trucks, buses and some construction machines. So they have introduced the hydraulics in the steering system. So what is the main difference in this particular power assisted rack and pinion steering system is we can see some additional components in this system. What are those additional components? There is a hydraulic pump, then there is a rotary control valve and there is a hydraulic cylinder, and there are certain fluid lines. There will be a regulator valve which is not shown here. Okay. How it works? So earlier was very simple. Driver used to rotate the steering wheel, shaft rotates, pinion moves this rack either this side or this side. Then because of the steering linkages, wheels move this side or that side. But what is happening here is instead of rotating or moving this rack with manual effort, the system allows to move this rack with the hydraulic force. Instead of manual effort through the shaft, the system allows to move this rack in the required direction, that is left or right, with the help of hydraulic force. That is the point to be noted in this system. How the hydraulic pressure comes here and how it works, let's have a brief look. First of all, let us go one by one. This is the layout. This is the pump used in the majority of the cars. This is called the Rotaryvane pump. The Rotaryvane pump construction looks like this. This is the housing with a circular inside path, and the center one, the gray one, is the rotor. The axis of the rotor and the housing are eccentric. They are not in same line. So it is eccentric. Why it is eccentric? It has to create a gap at one end to suck the oil and to deliver the oil. That is the purpose of this design. So the both axes are eccentric to each other. So the rotor is having slots to accommodate the sliding vanes. These are the vanes which freely slides in the grooves. The number of vanes may depend on the pump size, and the length of this rotor or housing depend on the pump size. Okay. When the pump starts rotating, because of the centrifugal action, always the vanes inside these grooves will be flying outwards and touching this housing. Okay. So we can see this construction looks like this. This is the housing. This is the rotor. This is the shaft, rotor shaft, and these are the blades or rotor vanes. Okay, you can see the gap here. So when the shaft's rotating, because of the centrifugal action, these vanes will be always touching to the housing. So you just observe here. Here the gap is very less. It's gradually increased. Again from here it started reducing. What is happening here? If this blade is coming like this rotating, and here because of the increased available space, a vacuum is generated and oil is pulled inside or sucked inside. Once it is reached this place, this is the maximum area, and again starts reducing the space here, means volume is reduced. When the volume starts reducing, whatever the oil is carried in between these two vanes is discharged through this outlet port. Again, same way, here the volume starts increasing and suction is created, oil is pulled inside, and volume start decreasing, pressure is created, oil is pumped outside. This is the function of the rotary pump. Animation, you can see oil is going, this oil is entering here and is being compressed and thrown or pumped outside. This is the job of the rotary pump, which is fitted in the majority of the vehicles. If you see from the outside in any car, the pumps looks like this. The pump get the drive from the engine accessory, okay, through a belt. This is the pump pulley which is driven by the engine belt. So as long as the engine is running, pump keeps running. And the volume of the oil dispensed by this pump depending upon the engine speed and also pump size. And there will be a pressure regulator valve which is designed to maintain the system pressure at specified rate. Next, circuit. This is the another important portion which is here. This one. This is called the rotary valve. The rotary valve, you can see where it is. This is the steering shaft and this is the pinion. In mechanical steering, there is no rotary valve because the directly pinion is connected. But there is a rotary valve installed above the pinion but at the end of the shaft, steering shaft. Means when the steering wheel is rotated, the shaft is rotated, and whatever inside this valve component, whatever is there, it is also rotated. Of course, this gear also is rotated. So when you dismantle this rotary valve, it looks like this. This is a pinion, this is a rotary valve, and this is a control valve shaft. This is called the torsion bar. This torsion bar is connected to the steering wheel shaft here. This is complete housing. When it is closed, it looks like this. Okay. Looks like this. So what happened? This torsion bar, the purpose of this torsion bar is to rotate this control valve shaft and also the spool. Whereas this housing also is having some ports to discharge the oil. You can see this, there are two ports to discharge the oil to the required end of the cylinder. And these two ports are, one is incoming from the pump, one is outgoing to the tank. Like that, four ports will be there. So this is the rack inside. Like this you can see the rack. This is the yoke rack adjustment. And in addition to the rack, there is a, you can see inside, there is a hydraulic cylinder inside. This is called the piston rod. This is a cylinder barrel or cylinder housing. This is the piston of the cylinder, and this both sides, this end and this end, this is called the end seal. So what happens? You just observe this blue color. Whenever we supply the oil to one side, the oil pressure acts on this piston. This is stationary. The oil pressure acts on the system, on the piston, and pushes this complete rod in this direction, means left side. So when the rod is pushed in this direction, whatever the tie rod connected here also moves, and this moves the steering linkages at the wheel. And whatever the oil is available here, the opposite side of the piston will be returned back to the oil reservoir, oil tank. And if you want to rotate the the vehicle in the other direction, the pressurized oil is supplied in this chamber, and the pressure acts on this piston this side. Earlier the pressure was acting on this side. Now the pressure acts on this side. So the entire rod is moved in this direction. So when the rod is moved in this direction, automatically the tie rod also is moved in this direction. So whatever oil is here will be returned to the tank. So the controlling of which direction, which chamber the oil has to be supplied is the controlling is done by this rotary valve. This is in fact like a brain of the steering system. Okay. The movement of this spool inside this housing controls the flow of the oil to the required direction. Pump is supplying the oil to the spool. When you rotate the steering, spool will decide which side of the piston that oil has to be supplied, and the opposite side oil will return back to the tank. When you assemble the cylinder, it looks like this. The oil is going. There are two oil pipes are there, like this, here one and here one. There will be a piston inside this housing, and there will be end seals here. Okay. This is all rack area. This one. So here the cylinder portion ends. This is all complete mechanical rack area. So these two tie rods are connected with ball joints at both ends of this thing, and other end this ball stud is connected, which is going to fix to the steering arm to the wheel hub. Now let us see how this valve works here. This you observe very clearly. This is the torsion bar what we discussed, okay, and this is called the outer valve. This is the housing, and this is the inner valve. Whatever we have seen, three components there: torsion bar, the other spool like component is the inner valve, and this is the outer valve. These all colored portions are the oil passages. Observe it very clearly. The oil from pump is coming in this pink color, and when it is neutral, it is simply going back to the tank. It will be recirculating. No steering action is initiated here. When you turn the steering to any one side, let us see what happens. This is a neutral portion like this. This is the neutral portion like this. Oil is coming like this and coming this actually, and again returning back, because none of the ports are joined with each other. But when the spool is rotated, or when the valve is rotated in one direction, let us see what happens. For example, this is rotated in the right side, means this complete inner one is rotated. The inner one is rotated to right, means with the help of the torsion bar, it is rotated. When it is rotated to the right, the oil hole, whatever is there here, is aligned with the outer spool oil passes. You see, the oil water is coming from the pump is aligned with this one. It's aligned and it is going and going to the one end of the piston like this. It's coming and going to the one end of the piston. So making this cylinder to move outward like this, means left side. When you turn the cylinder to the left, what is happening? See, this is moved like this, and oil passes whatever is coming from this one. So it was going to the right, and now it will go to it will be joining with this port. See, this is joined with this port. Joined with this port. When it joined with this port, oil will come like this, and come to the other side of this thing. So whatever the oil is this side is going to the going and joining with the inner spool. Okay, the discharging is coming through the inner spool and to the tank. So you rotate the steering to the left like this, it is matching to this one. Rotate the steering with the right, it is matching to this port. Like this, hydraulic oil is supplied to the required end of the cylinder. So the direction of the steering acts accordingly. Now, suppose this hydraulic system fails, means sometimes the belt may cut, or sometimes pump may fail, sometimes the hoses, one of the hoses may puncture or fail, sometimes this may seal fail. What happens? So when the hydraulic system fails, still the steering can be operated with this mechanical pinion by moving the rack. But the only difference will be the driver needs more effort when he want to operate mechanically. But of course it will be useful for the emergency purpose. That's how the power assisted steering system works. Next, what are the precautions to be taken in this hydraulic steering system or power is always we have to maintain the hydraulic fluid very clean and neat. No dust should enter into the system. Second thing, we should replace the oil as per the manufacturer's intervals, and we should use only the recommended grade of the oil. This is about the hydraulic system. In case you have any queries, you can always contact me through the email. Kindly subscribe to my channel and also inform your friends to subscribe and go through my videos. Please